In this video, we will be multiplying and dividing rational expressions and then simplifying those expressions as much as possible. So recall that a rational expression is a fraction in which the numerator and the denominator are polynomials. So for example, we have x minus 1 over 2x plus 5. And remember, we would need to state the restrictions because we cannot have the denominator equal to 0 because we cannot divide by 0. So in this case, x cannot equal negative 5 over 2. If x is equal to negative 5 over 2, then that would make the denominator equal to 0. And another example is x squared plus 4x minus 3 all over 2x. In this case, x cannot equal 0 because if x is 0, then our denominator would equal 0. And a third example is x to the power of 4 minus 2. So that's a rational expression for all real values of x. So if we're going to multiply rational expressions, we need to recall how to multiply rational numbers. So the rule when multiplying rational numbers, or in other words fractions, we would multiply the numerators together and then the denominators together. So that would equal to 3 over 8. However, when we are dividing rational numbers, our rule changes. So 1 over 2 divided by 3 over 4 actually becomes 1 over 2 multiplied by 4 over 3. So we take our second fraction, we flip it, and then we multiply both fractions together. So that becomes 4 over 6, and if we reduce that, it's actually 2 over 3. So to summarize what we're going to do when we're multiplying rational expressions, we're going to simplify and factor the numerators and denominators, and then multiply the numerators and multiply the denominators together. We're going to cancel out any of our common factors, and then determine our restrictions on our variables. So let's try this example. We need to simplify this as much as possible and then state our restrictions. So we have 3x cubed over 2y times 8y squared over 9x, and these are in factored form, and we just need to multiply these together. So 3x cubed times 8y squared is equal to 24x cubed y squared. And then 2y multiplied by 9x is 18xy. So I'm just putting the variables in alphabetical order. Now this can be simplified further. We can reduce these. So if we take these numbers, we can divide by 6. And then we're going to be left with 4 over 3. And if we take our x, so we have x to the power of 3 divided by x to the power of 1, we'll need to subtract our exponents, so that's going to just become x to the power of 2. And then if we look at our y, we have y to the power of 2 divided by y, and then in that case we're just left with y to the power of 1. So here's our simplified rational expression, but we'll need to state our restrictions because we started with an x and y in the denominator. So in this case, our restrictions are going to be x cannot equal 0 and y cannot equal 0. So here's our next example. You might think that we need to distribute these into the brackets, but we want it in factored form and it's already factored for us, so we're going to leave it like this. Now we can just multiply our numerators together and our denominators together. So when we do that, 2 times 6 will multiply those numbers, and that equals 12. And then x squared times y minus 1, then times x plus 5. So that's our numerator, and that's going to be all over 3x y squared x plus 5. Now we need to cancel out any common factors within the numerator and denominator, and we have an x plus 5 in both, so we can cross that out. And we're going to go step by step looking at our numbers and our common variables. So 12 over 3, that just turns into 4. X squared divided by x, that is just x. And we're going to keep this y minus 1 here in the numerator, and then we have y to the power of 2 in the denominator. Now you might think that you want to do y divided by y to the power of 2, but you can't do that because this factor right here is y minus 1. So this cannot be simplified any further. But we do need to state our restrictions on our two variables. So our two variables are x and y. And looking at our original expression, when x plus 5 is equal to 0, if x is equal to negative 5, that will make this whole denominator equal to 0, so x cannot be equal to negative 5. But on this side, we also have another x. So if x is 0, that denominator is equal to 0. So x cannot be 0 as well. And as you can see, we do have a y squared in the denominator. So if y is equal to 0, y squared is just equal to 0. So y cannot be 0. So in this next example, we have these two rational expressions that need to be multiplied. And as you can see, they need to be factored before we do that multiplication. So I want you to pause the video and factor all four polynomials. If you need to, you can do all of the work on the side. And then put the factored polynomials back into the rational expressions and then come back to the video. Here are all our polynomials factored. Now we need to multiply our two expressions together. So when we multiply, I don't want you to re-expand these. We're just going to multiply our numerators together and keep them in factored form. So it's x plus 2 times x plus 3 times x minus 5 and then times x plus 6 all over x minus 1 times x minus 5 times x plus 6 and times x plus 3. So then we can go ahead and cross out any of our common factors. It looks like we have an x plus 3 in the numerator and denominator. We have an x minus 5, and then we have an x plus 6 as well. So then our simplified rational expression is x plus 2 over x minus 1. Now we need to state restrictions on our variable. So if we look back to our factored form, we can look at all of our factors and see what x cannot be equal to. So starting with our first factor, x minus 1, if x is equal to positive 1, then x minus 1 is equal to 0. So x cannot be equal to positive 1. And then if we look at x minus 5, x cannot be equal to positive 5. And our next factor is x plus 6. So that means x cannot be equal to negative 6. And our last factor is x plus 3. So x cannot be equal to negative 3. And that is our final answer. So in our next couple examples, we're going to be dividing our rational expressions. So we'll still need to factor our numerators and our denominators as much as possible just to make it a little bit easier. And remember, when we're dividing our rational expressions, we need to take our second rational expression and flip it. So we're multiplying by the reciprocal. Then we'll need to multiply the numerators together, multiply the denominators together, cancel out any of our common factors, and determine our restrictions on our variable. So here's our first example. It's already in factored form, so there's no need to factor, but this should be division instead of multiplication. So since we are dividing, we're going to take this second rational expression and then flip it and change that to multiplication. So it's going to look like this. And then we're going to go ahead and multiply these. So negative 3 times 21 is negative 63, and then we'll put that a cubed, and then 7 times 12 is 84. We're going to multiply by this a to the power of 5. Now we want to simplify this as much as possible. So these numbers can be reduced if we divide by 21. So that just becomes negative 3 over 4. And then we got to divide this a to the power of 3 by a to the power of 5. So since they have the same base, we can subtract our exponents. So that becomes a to the power of negative 2. But something is wrong here with this a to the power of negative 2. We want to rewrite this with a positive exponent, so we got to bring that into the denominator. So that will just become negative 3 over 4 to the power of a, or 4a to the power of 2. Now we're going to state our restrictions. So in the beginning, we did not have variable in the restriction or in the denominator, but we did flip our fraction and we now have an a in the denominator. So in this case, since a is just being multiplied, our restriction here is that a cannot be equal to 0. So here's our next example, and it does look like this needs to be factored. So go ahead and factor this and come back to the video. So here are our expressions in factored form. Since we are dividing, we're keeping our first rational expression the same, and then we need to multiply by the reciprocal. So this x times x minus 3 moves to the numerator, and 5 times x plus 5 is now in the denominator. Now we need to do that multiplication. So this becomes 2x times x plus 3 and times x minus 3. Keep it in factored form, do not expand or distribute. In our denominator, when we multiply this, it becomes 5x to the power of 3 times x plus 3. Now we need to simplify this and cross out any of our common factors. So we do have a common factor in the numerator and denominator, and that's x plus 3. We can cross that out. And 2 over 5 cannot be reduced any further, so that will stay. X divided by x cubed is just x to the power of negative 2 and times x minus 3. So we have a negative exponent here, and we need to bring this into the denominator, so we can rewrite this with a positive exponent. So that becomes 2 times x minus 3 over 5x to the power of 2. And we have to state our restrictions. We need to find out what x cannot be equal to. So if you look at these factors, x to the power of 3 and x, we know that x cannot be equal to 0. And our next factor here is x minus 3. So that means x cannot be equal to positive 3. But we did something here when we were dividing our rational expressions. We had to flip our second rational expression. So that moved this x plus 3 into the denominator. So we got to take that into consideration when we're stating restrictions. So x cannot also be equal to negative 3. So here are your last two questions. In the first question, you're going to be multiplying these two rational expressions together. And then in the last question, you're going to be dividing these two rational expressions. So you need to simplify as much as you can and state your restrictions on your variables. Pause the video, do this all on your own, and then come back to check the answer. And here are the final solutions. Just make sure you've simplified both rational expressions correctly and you've stated all of the restrictions on the variable. When you are dividing rational expressions, make sure you consider the denominator before you actually flip the fraction and also after, so that you can get all of the possible restrictions on your variable.